It is now 8 p.m. Mountain Time, and we will be standing up the monthly Colorado Severe Weather Watch net here at the top of the hour. Good evening to everybody monitoring on the net. This is Net Control. My name is Matt. I'm located in Maple Grove, Minnesota. My call sign is K0LWC, Kilo 0 Lima Whiskey Charlie. The monthly Colorado Severe Weather Watch net is a monthly educational net focused on helping to further the education around severe weather. This net, we believe in collecting, analyzing, and trafficking the fastest possible real-time severe weather information while reporting severe weather as occurring to help preserve life and property. In Colorado, of course, we experience many types of extreme weather: blizzards, tornadoes, hail, microbursts, non-thunderstorm damaging wind events, floods, fires, droughts, and heat waves. You're most likely to hear actual weather activations during tornado season, though significant large-scale winter storms or flash flooding may also warrant net activation. Break. Now, if you guys are on the SkyHubLink email list, you got 2 emails today, so I apologize about that. My first email had a double with the email from last month in addition to the new one. Hopefully you're able to find the link. Tonight's topic of discussion after check-ins, we're going to be talking about velocity, or understanding the wind within a thunderstorm. Also going to talk a little bit more about radar basics and understanding the importance of how far a thunderstorm is away from a radar site and what that means as you interpret the radar looking for damaging winds and or rotation. I said the better you get at spotting rotation, typically once you get really good, you can probably get a 5, 10, 15, sometimes even a 20-minute jump on a tornado warning before it's actually issued by NWS, because you're seeing it just like the warning coordinator is seeing it. And I said, when you know what you're looking for, you can kind of be a few steps ahead of the game. Brick. So again, radar velocity is the topic tonight. If you did not make the net last month, we do kind of an interesting and different format that at least I haven't heard throughout the state of Colorado to this point. You want to pull out your phone or hop on the desktop computer and go to coloradosevereweather.net/May, M-A-Y. That's coloradosevereweather.net/May. And those will be the pictures that we'll be using for tonight's educational portion of the net. It should also be noted that Jack KE0VH will be recording tonight's net. So everything will be recorded, and I believe Jack has plans to kind of package things up for those folks that might miss this, so that way I said they can take advantage of the education after the fact if you're not able to check in tonight. Break. All right, so we're going to get onto the educational portion of the net, and then allow for some Q&A as well. So if you have questions, don't worry, we'll have a Q&A session here in the back end of the net. Tonight, we're going to be talking about radar velocity. Now, remember, this is an interactive net, so what you want to do is pull out your cell phone if you can. If you're driving, don't do this. But if you're at home on a desktop or you got an iPad in front of you or you got your phone, go to coloradosevereweather.net/May, M-A-Y. Again, that's coloradosevereweather.net/May. And that will be our visual guide as we walk through understanding a little bit about radar velocity. Now, I want to prime Daryl, because I said I always value Daryl's opinion on this. So, Daryl, I'm probably going to toss it to you to also provide some color here, because I said you have a wealth of experience and knowledge that'll be good to share across the net as well. So, prepare yourself now for me to put you on the spot with different questions. Okay, so again, you should be staring at the Understanding Radar Velocities page at coloradosevereweather.net/May, and that is the focus of tonight's discussion. So very simply, most people are used to watching radar and looking at all of the greens, the yellows, the reds, the purples on occasion, which is reflectivity. Now, of course, reflectivity, what most people think of when they think of radar, is looking at essentially the precipitation that is falling. Velocity is measuring what the winds are doing. So it really has nothing to do with, how much rain is falling or, how much hail is there or not there. It's really about understanding what the winds are doing inside of a thunderstorm. But one of the key principles, always very important to remember, is to understand how the curvature of the Earth affects weather radar, because it's always something we have to have in the back of our mind when we're looking at radar and interpreting it on the fly. How far a storm away is away from the radar site makes a big difference in how you interpret what you're actually looking at. And that's exactly what we're going to dive to here in Figure 1. And let me reset. Here on Figure 1, you see that there's two different radar sites, and this is very common, right? Many NWS sites, and that is certainly the case across much of Colorado, overlap. So you can actually pick probably 2 or 3 different radar sites to look at any one given storm. I know we were doing some of that with some of the first storms that were firing up last week across the Front Range. Now, under the BMX site, which is the one with the yellow lines, that radar site is further away. Now, if you take a look, you'll notice that the radar beam is scanning the top levels of the storm, or the mid and upper levels. You'll see that there's actually 4 different lines. Now, what those 4 lines represent are what you often find on radar called tilts. Tilts start at the lowest, which is 0.5 degrees, which is exactly what you might expect. That means the radar beam is looking 0.5 degrees up over the horizon. However, last time I checked, although there is some debate, as a little bit of a sarcastic joke, the Earth is not flat. So this does actually have an impact on how radar is impacted in terms of what it can see at what distance away, because that curvature of the Earth is definitely going to throw a wrench into things. Let me break. So the reason this is so important is you have to understand the further a storm is away from the radar that you are using to scan that storm, and again, when you're wondering about what radar apps are good, Radar Scope is a fantastic one. It's a great thing for your phone and for your iPad. There's also a Windows version of it. So the further from the radar site, the higher up in the storm the radar is able to scan. Now, if you look at MXX on the right, you'll see that that storm's a lot closer to the radar site. Maybe that's 10, 20, 30 miles away, 40 miles away. There you're scanning at the lower levels of the storm, which, of course, anytime we're looking at storms, we want to know what's going on in the lowest levels, because sometimes there can be a drastic difference between what the radar shows at the upper levels but what's actually occurring at the ground, which, of course, is what we care about the most. And that's why we're looking at damaging wind or rotation, potential tornadoes. As I'm looking at those radar products, I'm always in the back of my mind thinking, okay, how far away am I? And some radar products, including Radar Scope, will actually give you a tool and tell you, based on the distance from the radar site, you're looking at so many feet above the ground. It could be 2,000 or 3,000, could be 1,000 feet, could be 6,000, 7,000, 10,000 feet you're looking at, but the actual radar app will tell you that. That's a really great feature that you also find on Radar Scope. Let me reset. When we take a look at Figure 1, one thing to keep in mind is the further away you are from the radar site, just because you see something that may indicate rotation, it may not actually mean tornadic potential, because a lot of times we see mid and upper level rotation in a storm that is a prolific hail producer. So you may even see broad rotation, but if you're 100 miles out from the radar site, I would say, well, of course you're seeing broad rotation because that's that mesocyclone. The whole storm is spinning. And yes, there's always a threat of a tornado if you have this mesocyclone. But again, broad rotation, especially far out from the radar site, very likely could just mean that it's a very strong and intense storm, and it's probably a hail producer. Now, again, if you're on a radar site very close, and this is the great thing about Denver, Denver's got a radar site right there. Cheyenne is not that far away, and Pueblo. So the Front Range actually has some really, really great coverage and overlap where you're usually not ever too far away. The only time we get too far away is when we start stretching out the Front Range and getting towards Kansas, and then the Goodland eventually comes into play. But still, there's kind of some space in there where it's a little iffy. But right along the I-25 corridor, we always have really great coverage of our radar. Let me reset. Let me see that control. So that's the thing I'm trying to drive home. Because of that curvature of the Earth, you want to make sure you understand how far away from the storm you are with the radar site you're using. Understand that if you're looking at a faraway storm, you're looking at probably the 6,000, 7,000, 10,000 foot level, which is giving you clues, but it's not giving you a great picture of the ground truth, as you may have heard in spotter class. If you're 30, 40, 50, 60 miles away, you're probably scanning anywhere from, if you're right near Denver, you're scanning probably 800 feet, 600 feet above the ground, which is, again, ground truth, probably very close to what's occurring on the ground. And then, you're scanning 1,000 feet, 2,000 feet. That's much stronger indication of what's actually occurring. So understand, curvature of the Earth does play a role. And you can actually change your tilts in a radar app. If you have a storm that is near the radar site, but you want to scan up a little higher, you can change the tilt and get a scan that's higher up because you want to understand what's happening at the mid-levels and the low levels. So when you're really close to a radar site, you definitely have more options to scan the low and the mid-levels, which is really nice. But when you get further away, you only got the option to scan probably the upper mid-levels and then way up top, which is probably not going to be super valuable. Let me reset. That explains curvature of the Earth and how it does impact radar. Let's move down to figure number 2. So oftentimes people wonder, what am I looking for when it comes to tornadic activity on radar? Well, this should be a pretty good explanation for you. Now, granted, the colors on the right side of figure 2 are blue and red. When we take a look at some of the other figures further down, you'll see it's usually red and green. Red and green is what you'll see on radar. This particular chart just happens to use blue. I wish it was green, but it's not. So just think of blue as green. When we have two different velocity colors next to each other, as you can see from the chart on the left, it indicates rotation because what you're measuring is the red velocity returns means that wind is going away from the radar site. And it's always relative to where the radar is located. Anywhere you see red on a velocity scan, it means that the wind is going away from the radar beam and the radar site. If you see green, that means wind that is coming towards. So if you have wind that's coming towards the radar, directly adjacent to wind that's going away from the radar, as you can see represented on the left-hand side of the chart, what you have really is rotation, circular motion, when they're butted up right against each other. Let me reset. What I like about this is that you do see on the scale on the bottom, on the right-hand graph, figure 2, you'll see that there is a bar for 0, 5, 10, and 15, or distance from the radar. So if you're really close to the radar, you can get a really tight couplet, and that means it's really bright, really close together, which we'll see here in figure 3. The further you are from the radar site, you may only be getting kind of a broader look at the mid-levels, and it may not look as tight and really defined as a bright circular couplet, as we call it, on radar velocity. But let's take a look at that. Figure 3. If you scroll down, now this should look like a classic picture on the left. This is a reflectivity image, it's a very classic radar image of a hook echo on a supercell structure. This is about as textbook as it gets when we're looking for just a monster supercell with an obvious tornado on the ground. So let's take a look at figure 3 and walk through and take a look at what we're actually seeing here on radar. Let me reset. Well, nobody's seen that control. So now what's great about this is a very easy storm to detect what's happening structure-wise. You see the big hook dangling. Remember we talked about correlation coefficient if you were in last month's net? This would be a very obvious also return on correlation coefficient. But note, you have the big, we call it debris ball on the reflectivity image, which is a bright red return right in the center of the hook, typically indicative of debris being picked up by reflectivity. You'll notice the radar site's actually just north of Burleson there. You see where there's a clear circle of dead space above the radar site. So the radar is very close to this. So this has got a great look. Now, if you go over to the right to velocity, notice, just like we saw in figure 2, we have bright reds, or outbound winds, right next to an adjacent bright green and inbound winds. So again, we definitely have rotation. So when you think about red and green, just think, okay, wind going away, wind coming towards, and just visualize that in your mind with the greens and the reds. One thing that really helps me when you're looking at velocity, and you're certainly new to it, is put it into motion. Put it on a loop. And you really can then kind of see how the winds are shifting and moving from frame to frame. It really helps you kind of visualize the wind and the movements if you just put a little motion to it. So put it in motion, animate it. That's a great tip that I always use when I'm trying to track down, what's happening from a shear perspective, rotation perspective on a given storm. So we'll walk through this some more. So again, I wouldn't even really need to look at velocity to know that there's a tornado with a storm, just based on experience. But if I'm looking at assessing, I look at reflectivity, obvious, supercell, hook echo, inflow. I mean, everything is classic. Velocity, bright outbounds, really strong inbounds. Even on this radar product, there's what's called a TVS, or tornadic vortex signature. That's that little kind of upside-down triangle. That's signifying really strong shear right where that couplet meets, those inbounds and outbounds. Basically, it's a marker indicating that the radar is saying, this is almost certainly a tornado, although, believe me, TBSs are not 100%. They give a lot of false returns at times. So that's, again, a classic look. Now, if you look throughout the velocity picture there on the right of Figure 3, there are plenty of other places where you see red by green. You're wondering, well, I see red next to green elsewhere. Isn't that all rotation? It's not. What you want to look for is where you see increasing gradients of color. So you want to really see where it goes from a little bit of a lighter red to a darker red, right, where you're seeing winds speeding up and getting closer together. Because there's a lot of places where reds and green touches, but there's a lot of craziness and shear and wind moving around in a storm. What you're looking for is bright colors coming together and getting brighter or getting stronger. That would indicate that rotation is strengthening. And depending on at what level of the storm you're looking at, that could be mid-level rotation or low-level rotation. Obviously, this storm had a tornado going on at the time, but if I saw this on radar with no spotters around, or nothing had been reported, I'd be asking people, does anybody have eyes on this? What are you seeing? I'm almost certain there's a wall cloud, probably a funnel at this point. I would want to quickly get information on this particular cell if this was actually occurring. Let me reset. Move to Figure 4. Now, Figure 4, I threw this in there because not every storm is going to look like a classic textbook supercell with a hook. I mean, it's great when they do look like that and the setup's perfect and they look beautiful. But a lot of times you get them where they're messy. This is a messy one. When you take a look at the reflectivity on the left-hand side, nothing really stands out. It looks like it's just part of a line of storms, which it is. But what you don't see in the reflectivity is hiding when you flip over to velocity. Now take a look at velocity. You have brightening greens, right, inbound winds toward the radar site. And you have some really strong outbound winds, again, right next to each other. So in this case, the arrow is pointing right to where the potential tornado would be. So wherever those two things meet would be where the theoretical tornado location would be. So if I was looking at this, I'd be telling folks in the area like, hey, is anyone near Fultondale? What are you seeing? Looks to be passing just to maybe a mile or two north of Fultondale at this time. Things like that. I'm looking for right where those two areas meet. But again, reflectivity doesn't really give you a good picture of what's happening. You really got to switch to, in this case, velocity to see, oh, wow, there is a couplet there. There is strong inbounds next to strong outbounds rotating. And so that's a tricky one. You'll see that a lot. Not everything is a classic hook echo. Sometimes it's messy. In fact, the storms we had last week were kind of that way too. They weren't necessarily classic. They're a little messy. And you get that with what's called high precipitation storms. Thankfully, Colorado actually has a lot of LP storms or low precip, which means they're a lot easier to identify the structure on. But there are storms in Colorado that are HP, and then you get real messy. But usually you see storms like this that look in this fashion when you get down into Mississippi, Louisiana, Texas, with a lot of moisture. It can get really, really, really messy. Let's reset and go to Figure 5. There will be CNET control. So Figure 5 here, and if you're just joining in, you want to follow along, and you're like, what are they talking about? ColoradoSevereWeather.net/May, M-A-Y, and you'll find these pictures we're looking at here. So what about damaging winds? Same thing. Rotation is one thing, but velocity is also how we understand what's happening from a potential damaging wind perspective. So taking a look at the right side of this Figure 5, it's messy. It's a squall line. I mean, again, as I look at this, I can see there's a couple areas of interest that I'd be looking at. One of them would be, first off, the radar is actually to the west, to the left of these figures. So it's behind the storm. How do we know that? Well, we know that the outbound winds are going east, so that means the radar is back to the west. So again, the reds you see on the velocity image on the left-hand side, and those are winds going away from the radar site. They are going in the direction of the storm. So that would be a location of where you may see some damaging winds. In this case, they're pointing their arrows near Rock Hill, just east of Lowry's, and then just south of Chester. We see these bright red returns coming up. Now, again, this is not terribly far from the radar site. This is probably at about 1,000 feet. We're seeing winds of 70 to 80 miles per hour depicted on radar. Let me reset. Well, that's one thing I'm looking at. As I look at this particular image, I'm seeing that there is these areas of really strong outbounds. So those would be areas where if I had spotters or people, I'd be letting them know, hey, this would be an area where some damaging wind could make it down to the surface. This would be certainly, a warned storm from a damaging wind perspective. But there's a couple other things to note. Now, when we take a look at what's happening down near Chester, you'll see we have these really strong winds coming in just south of town, but we also have some inbound coming in. Now, what you see in reflectivity with Chester, you see it looks like a little notch, a little little hookish, right? A little punch in the front of that storm. That's inflow. That's the cell there getting some warm, moist air that's feeding it. The warm, moist inflow is the fuel for the thunderstorm. However, in a line like this, not a supercell in a classic sense, but a very long squall line, when you get these little punches, these little notches in the front side, and you see this kind of like return near Chester where you have some inbounds next to some strong outbounds, occasionally you can get a weak tornado that forms in that area. So that would be one spot I'd be watching and looking for that couplet, that tightening, to turn from just pure inflow to maybe something a little bit more, a little bit stronger rotation from one frame to the next. So that would be a cue for me visually to watch what's happening just to the east of Chester, because that could be a potential for tornadic activity between there and out towards Lancaster. But still, there is still really strong winds in that area too. Just south of Chester, you see all that 80-mile-an-hour wind just blowing through. So again, just south of town, you'd probably be getting some wind damage. Let me reset. So depending on which way the storms are moving, you got to remember, always, red and green is always relative to the radar's location. So red means from the radar site, this is where the wind's going away and this is where it's coming towards. Always remember that. It's always relative to the radar. Let's look at a figure 6, because here's another example of damaging wind. So this is a bow echo. This is mostly seen more in the Midwest and across the northern plains. You don't get them as much in Colorado. Occasionally you do. But typically what ends up happening is you get a lot of single cell structures in Colorado, which then congeal and come into a line of thunderstorms as you get into Kansas, and they become more like this. But taking a look at the right, you'll see that the bow echo is identified. And then on the left-hand side, it's showing velocity to say, at 650 feet, because the radar is just to the southwest side of this picture. If you take a look where it says falls in the lower left corner, that's essentially right where the radar site is. So this is, really close to the radar. So at 650 feet above ground level, they're detecting 108 mile per hour winds. So the winds here are probably 90 to 100 miles an hour at the ground, almost certainly, in this particular case. Let me reset. These are LWC. So what's unique about this is when we take a look at the reflectivity on the right, it really doesn't look that strong, right? It doesn't look that impressive. Now, granted, it is close to the radar, so that's kind of skewing it a little bit. Typically, when you're super close to the radar, you might get a little bit less of a return because the radar really doesn't understand what's happening at the highest levels and understand how tall that storm really is. But when you take a look at velocity, it's a whole different picture. We can see just how strong that storm really is, with 100-mile-an-hour winds probably almost likely making it down to the surface. You can see, again, where those really strong pockets of winds are with the arrows there on the left-hand side of the velocity. So again, now, if this occurred on the other side of town, on the west side of wherever this radar site is located, these would not be reds, right? They would be greens, because these storms are coming at the radar in that case, not going away from it. So again, the color would change. But again, you can just see how intense and how bright those winds are. There's other factors that can affect whether damaging wind makes it down to the ground level. But again, these are telltale signs of, like, this is where the highest chance of seeing damaging straight line winds is occurring. So that's it. That's the quick crash course on velocity. Again, what you're always looking for is a really tight gradient between red and green, and you want to see relatively bright colors, meaning stronger winds. The stronger and deeper the color, the brighter the color, the stronger the winds are. And usually we measure what's called gate-to-gate shear. We can measure what's the strongest return in the green section of the couplet, and what's the strongest winds in the red section of the couplet, and then we add those two together, and that gives us a sense of just how strong that rotation is. So again, the stronger the colors, the brighter the colors, the closer they are together, the better the chance that you are having a real tornadic potential at ground level. Also, the stronger the colors are for a severe thunderstorm warning, or even with the supercell, look for other bright colors outside of the tornadic area, and you can be looking at a chance for a downburst or for damaging straight line winds that are coming out. So again, this is not measuring precipitation. It's red and green, and it's measuring wind and wind speeds. And again, that's really important, obviously, when you're looking for tornadoes or damaging winds or something like that. So with that, we're going to move into the Q&A to see if anybody has any questions or things they want to follow up on any of these figures. If you do, please call now. We can just answer anybody's questions. This is K0LWC Net Control for tonight's Q&A. Right, not hearing anything out there. Let me add in a few more things that I think are relevant and important to share. So sometimes people will say, you know, this, I see rotation. Why hasn't been warned yet? Why is there no tornado warning? Keep in mind that for a warning to be issued, typically, if there's nothing being reported on the ground, as in any kind of ground truth, I'm talking wall clouds, funnel clouds, rotation, if no one's reported anything, and it's just radar, they want to see persistent rotation, because a storm can spin up and kind of get a little rotation going for maybe 5 or 10 minutes, and then it goes away. That's very common, definitely depending on the setup of the storm. So they want to see persistent, where it's 2, 3 frames, and then they're going to start writing the warning to be put out. And that takes a few minutes. That takes probably a good 5 minutes to write it up. So I said, from the time that you first see rotation beginning to strengthen, beginning to tighten up, it may take 10 or 15 minutes for that warning to come out, which, again, that's the one thing that everyone's trying to figure out, how to reduce that lead time. But again, plenty of times when you're watching a storm, and again, put it in motion, put it in animation, take a look at that velocity and watch it move, and you can really get a sense in visualizing that wind and how it's changing from slide to slide, from scan to scan. When you're watching these storms, you typically can get a jump on a warning 10 to 15 minutes before you ever see a warning come out. If you're watching and you're really getting good and knowing what you're looking for. Let me reset. Now, let's say there was a storm out near Deer Trail, hypothetically speaking. That's very close to the Denver airport. It's very close to the radar out there, because that's the radar site location out by DIA. You know, I would be taking a look at the lowest level of the storm. I'd be scanning. I'd be probably only a few hundred feet above the ground. That's fantastic. I'd be looking at that. That's the first and foremost, most important thing. If I see something WC. So the best thing I can tell you is it takes practice. You know, I've been doing this for so long. I've watched so many storm systems in my life, just from radar. The more you see it, you get to recognize patterns and trends, and you kind of can know what it's going to do, and you're starting to put together a bigger integrated picture, right? So the more you do it, the better you get. There's no doubt about it. I mean, if there's ever a storm outbreak, you can always dial up radar anywhere in the country and practice. It doesn't have to always be in Colorado, right? You can dial up Texas or Mississippi or Oklahoma and do this on a weather day to continue to practice and get better and better and better. So velocity, very, very important. It's what we use, again, to figure out damaging wind and tornado potential. That is the product. To be able to sample the winds inside of a thunderstorm. So again, one more quick pass. Anybody with any questions, anything you want to ask, want to inquire about, that wasn't clear, that you're wondering about, there are no bad questions. If you have one, please come now. This is Kilo 0 Lima Whiskey Charlie Net Control.
Kilo 0 Lima Whiskey Charlie, November 0 Lima Bravo Hotel. Someone just told me about this net. Pardon my ignorance, but I've been at Skywarn for a long time and I've never heard of it. Can you tell me, are you use the net control all the time, or how does it work?
0LBH, A0LWC. Yeah, absolutely. So, new net, this is only the second time we've met. We did one in April of last year with our first monthly net, and then this is our second one here in May. We used to be on another talk group. We would do a DMR-based severe weather net for the state of Colorado. And then recently for this season, we migrated over to the SkyHubLink system. So in addition to standing up an actual severe weather net where we're tracking ongoing weather, which of course is not the case tonight, we also have a monthly informational educational net, which is what tonight is. And it's on the first Tuesday of every month at 8 p.m. Mountain Time. So right now we're going through some visuals at coloradosevereweather.net/May is where you can find out what we're looking at. In addition to, you can browse the website and learn more information. But yeah, this is a relatively new thing for SkyHubLink. And something that, again, we'll be doing on a monthly basis. And right now, I'm the only net control. But I said in the future, we might move to a bi-monthly, I shouldn't say bi-monthly, a bi-weekly, twice a month format, and pick up another net control. But yeah, so this is our second educational net so far here on SkyHubLink. So a relatively new thing.
Good to know. Can you throw me that website again, please?
The net website is coloradosevereweather.net. coloradosevereweather.net. And what we're looking at tonight is a little extra page there, which you've got to type in the URL to find it, which is coloradosevereweather.net/May, M-A-Y, the month of May, is what we're looking at here to kind of follow along with these pictures. So that is coloradosevereweather.net/May. Anybody else have any questions for tonight's net on radar velocity? Things that you always wondered. Again, there are no bad questions for anything. Ask away here. We got about 8 minutes left in the net. If we have any questions, I'm happy to answer anything you got. So if you have anything, please come now. This is Kilo Zero, Lima Whiskey Charlie, net control for the monthly Colorado Severe Weather Watch net.
W30RR. Yeah, Matt, I heard you call me there. Unfortunately, I was on the roof installing an ADVS system antenna, so I got that running up and going now. Maybe you could point out to people, since you're talking about the velocity, what they may see or what colors they should look for when a derecho would show up on that. Kind of explain the colors and how shape it would be, what to look for.
For UFOs, could you touch on the bow echo again and why that was important? I kind of missed that part of it there. Just recap that real quick for me, please.
All right, Mike, I got your question on the bow echo, and then Daryl, I heard you in there. It may have been a network issue on my end, but can you just repeat that? You broke up right in the middle of it. It's probably an internet issue on my end. So Daryl, I'll just get a repeat on yours, and then I'll also grab Mike's there. But Daryl, just another rehash of what you had there.
Yeah, man, I wasn't sure if you had covered, like the derechos and what they're going to look like when they're bowing on that velocity radar, what colors they're going to look for, and what type of wind speed they could expect out of something like that.
All right, perfect. So kind of a similar thing between Mike and Daryl there with bow echoes and derechos. So derechos, yes, we love those in the Midwest. They are a lot of fun. So a derecho is a really, 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 really long track wind event. In fact, they're probably more dangerous than a tornado just because of the mass area they'll cover. So again, when you're looking at, and a derecho is basically, for lack of a simple way to explain it, a really long bow echo that goes on forever. Now, a bow echo is named that because on reflectivity it looks like a bow. It's kind of arcing forward in the center of the storm, and it has a very kind of fine leading edge in the center of that bow, just like a bow and arrow would. And then it kind of bends backwards on the northern and southern parts of the storm. So in a bow echo, to cover that first, typically what you're going to look for is wherever on reflectivity you see the shortest amount of reflectivity. So going from red to nothing at all. So if it goes from no radar return whatsoever, or even a light blue, to red very quickly, that's a very sharp gradient on reflectivity, and it's usually bowing out, it's at the tip of that bow, that's going to be where you see and you expect the strongest amount of wind. And let me tack on a few things that, and Daryl can fill in the blanks for me as well here, but let me reset. But so when you're looking at a bow echo, again, what you're looking for is a pretty tight gradient, not always, but that's one indicative sign. You're typically going to find that your velocities are actually very, very high. They might actually even go, like, let's say we're talking about inbound velocities. We talk about greens and reds. In the case of a derecho, a long track, very, very severe damaging wind event, or a really strong bow echo, you might actually have greens that look more whitish or bluish, which is just incredibly strong. Another telltale sign you're going to look for in a bow echo where a storm is bowing is you're going to look for what's called a rear inflow jet. A rear inflow jet just means that there's little notches behind the storm where it's almost like there's really, really low areas of reflectivity. So there's a red in the bow, and then right behind it there's a little notch of green. It looks like a little punch, just a little notch has been carved out behind the storm. When you see those little carved out notches behind that bow on the back side of that bow, that's also indicative of probably where you're going to find some real strong damaging wind potential. You could see winds in a bow echo scenario or derecho be much higher than you would from a standard severe thunderstorm warning for 50, 60, 70 mile an hour winds. You're talking 100 to 140, 145 even at the mid-levels in a very, very, very strong damaging wind event, which we do get these quite a bit here in the Midwest. They can be quite damaging. In fact, you may recall Iowa had a very significant one. Daryl, please fill in the gaps here for everybody on the net while I get this uploaded.
Yeah, I'm not sure where you want to go. I know you did talk about that Iowa derecho that went through, and man, what a mess. There was a documentary on that on the Weather Channel the other night. And I didn't realize the amount of damage that they received from those the derecho that went through. I mean, like you said, they're probably more dangerous than a tornado. And some of the damage that you saw, it looked like a tornado. One gentleman, he was in a factory, his own business, and the building started to shake and got crazy, and he's filming it, and then all of a sudden the roof peeled off, and then the whole building just got wiped away. And the only thing that saved him was the interior bathroom. And when he got outside, everything surrounding him for about a mile was flattened. So, yeah, they can be very dangerous. Really don't get those out here in Wyoming or in Colorado, but some of those straight line winds, some of the smaller ones that we get, they can be damaging. And we'll send it back to net control.
Yeah, thanks so much, Daryl. Yeah, they can really do a number. Like I said, they typically will find that, we mentioned that earlier in the net, that the damaging wind sets up, typically once you get into Kansas and Nebraska, they start out as more single cells, supercells, things like that in Colorado, and then they set up to more of a damaging wind bow echo as they move out further towards the plains of Kansas and Nebraska. And they usually get hit at night with that. Once they get out that way. And that's what we're always worried about here. I'm not really worried about a tornado here in Minnesota as much as I'm worried about a very long derecho type event that moves in from the Dakotas overnight. That's actually, or even Iowa, if it's going on a northeasterly track. That concerns me more than a tornado would, honestly, which most people would be like, what, are you serious? But yeah, that's my concern. But I did upload something that shows a derecho, which it went across Iowa that Daryl just mentioned. It's a little pixelated, so that's kind of a bummer. So you'll see that the storm started way up in southeast South Dakota and northeast Nebraska and moved all the way to Ohio and did damage all along that line. Now, this is a pretty classic derecho. It looks pretty messy, really high precipitation, but I want to call it a few things. So if you look at the 1 p.m., the 1 p.m. is where it's in eastern Iowa. You'll see it has a really, really strong bow to it, right? It's really curved and it's really hooked right there. There is something that happens, again, you guys probably wouldn't see it close to the front range, what's called a rotating comma head when it comes to bow echoes. We're seeing that in that 1 p.m. slot where it almost looks like it's curving back like a backward C. Sometimes there's so much vorticity and rotation up in the top of that storm, we can have what's called a rotating comma head, where inside that rotating comma head, where it's literally spinning like a comma shape to it, you can actually have a weak tornado form in there. So we're looking at the ratios or really strong bow echoes. I'm usually looking at that comma head area, watching for rotation in case there's a brief spin up of a tornado. But what we're looking at is, if you take a look at the 12 p.m., if you look at 12 p.m., notice how there's these backward C shapes. There's two of them. There's a smaller one on the northern part of that cell, and that's that line. And there's a much wider, broader backward C shape to the line further south, right? It looks like a backward C in yellow. Those are the rear inflow jets. Those are the punch behind the storm that's going to drive that damaging wind out ahead of that thunderstorm line. So that's one of those telltale signs you're looking for, is those really big punches in the backside of the storm. And if we were to flip this over to velocity, you would see really, really, really strong velocity returns right in those same areas where you see these backward C's behind the storm. Wherever you see these punches from behind, in the leading edge of the storm on the eastern side, on the front of the storm, wherever the leading edge is where it's mostly bowed out and it's the very front of that storm, that's where you're going to have the greatest potential of damaging wind. And let me reset. LWC. And if you go to figure 6 again, this is the damaging wind example. When you take a look at the bow echo, notice where the arrow is pointing. You see how the arrow is pointing to an area where, I know it's very messy, but again, usually things aren't very textbook. There's always messiness to a lot of these setups. You'll notice that the area that's pointed out as the bow echo, that is the very eastern edge of the storm. Nothing else is really in front of it. You see how it curves back to the southwest as you go to the lower left corner of the picture? And then if you go up north and west of the bow echo, it bends back to the north and west. That is the leading part of the bow. That is the very, very eastern leading edge. And you can tell that's where the strongest winds are located. That corresponds with the leading edge on reflectivity, and that's also on velocity where you're seeing some of the strongest outbound winds. So again, that is the leading edge of that thunderstorm. And again, you're looking for that when you're looking at a bow echo. Also notice that the gradient between where there is almost no echo, it's very, very light blue, to where it is red, and it is in the actual underneath the storm, it's what? a mile. It's a very tight gradient. That's another little telltale sign that you'll often see in the very front end of the bow. Does that help out there, Mike? Do you have any follow-ups there? KD0 UFO from K0LWC Net Control.
That explained it very well. I'm originally from the Quad Cities, and that derecho rolled through there and caused a lot of damage. I know people that were damaged by it. That was quite the event. KD0 UFO, thanks for that explanation.
That was helpful. And again, that last figure that I added, I know it's a little blurry, but when you see those backward C's, those punches in the back of the storms, in the back of the squall line, where there's not much reflectivity, and you can really see the backward C shapes. Again, on the leading edge, in the front of that backward C, in the front of that storm cell, man, that's where there's going to be some wind. And I know when it went through central Iowa, right where it's kind of showing as Des Moines area, yeah, it was a punch and a half, and even off in eastern Iowa on the 1 p.m. frame there. It was really something else. But yeah, that storm did damage. Again, just think of that. All the way from Nebraska to Ohio. And I mean, I'm talking widespread damage. I can't even remember how much money was lost in crops and damage to buildings. And yeah, Daryl said it looked like a tornado went through, because these winds are 100, 125. I mean, that's tornadic level winds. Granted, these are straight line winds. So yeah, that was just a devastating storm. Looking for another good example of what we call a rear inflow jet, go to figure 5. And if you take a look at figure 5 on the right-hand side of the image, you'll see just to the east of York, you'll see where there's an area, it looks like there's this really lighter shade of yellow that punches in behind that strongest part of the cell. It's kind of this V shape of yellow right to the east of York, and it dives southeast. You see how it's a little bit less reflectivity right there? Also notice that right in that same area, that's where you have 70 to 80 mile an hour winds. It's right lined up with that rear inflow notch there and that punch, that jet. I'm also seeing that same thing happen with the jet that's just near Sharon. See that kind of green, weak area of reflectivity coming in the backside? You also have some strong winds that are coming through that area as well. So again, those little notches in the back are good telltale signs. And to refresh on figure 5, in case it's helpful, when you get a little notch in the front, like we see near Chester in figure 5, and reflectivity on the right-hand side, that would be an area I would keep an eye on where we see a little inflow coming in. Sometimes those can get a little hook established on the leading edge of that line, and you can get a brief tornado that spins up on the front of the leading edge of a squall line like that. So it's probably not imminent from what I can see in this picture, but I'd be keeping an eye on it to see if anything tightens up in that little notch there near Chester. One last call for any more questions about radar velocity, curvature of the Earth. Maybe you think the Earth's flat. I don't know. Anything you got for radar velocity and limitations of radar. We'll take one last call for questions. And then I'm going to kick it to Daryl if he's still in there, because Daryl, I'm not sure if you heard my tip. I always say put it into motion. The easiest thing to do when you're looking at velocity is don't look at a static, still image. Put it into motion and take a look at it. It's so much easier to visualize the winds and how they're moving when you're actually watching it frame by frame. But before I move to Daryl for his thoughts on that and any other tips he has, any other questions on radar velocity, please come now. This is K0LWC Net Control.
Yeah, man, I agree with you. Definitely put it into motion. In fact, we were watching that tornado that was out in Lamar 2 days ago. I was seeing the wraparound long before they put out a tornado warning. And I kept saying to myself, why have they not issued a warning yet? And in about 5 to 10 minutes, they finally issued a warning. And it's a rotation, as you watched it, you could see it rotating on the velocity. And it got real tight in one area. And then spotters on the ground confirmed that there was a tornado on the ground in that area. And then again, it touched down just east in Granada, I think the town is, right before it got to Holly. So, yeah, I definitely agree. I always put it into motion, and it will give you an idea of what's really going on, especially with some of the tilts that you have to look at. You know, here in Cheyenne, as soon as the storms are getting really close to our radar ball, we have to shift those tilts up because the storms are actually going too close to the radar to see it. So that kind of helps, and, you know, tinker around with it when you see some radar and severe weather. Just go on the velocities and play around with some of the settings on that, especially on radar scope. That's a real good one, like you said earlier, Matt. W30RR on the SkyHubLink. Send it back to you.
Totally, couldn't agree more, Daryl. I said motion is key. Like I said, if there's storms happening somewhere, go bounce down there, put the velocity on, practice, take a look at things, take a look at tornado warnings, and see how they kind of started, put it in motion, take a look at it before it was warned, take a peek at it, and then you can kind of get a sense of what they saw when they issued the warning. And yeah, that cone of silence is killer. We were talking about that earlier in the net. When you get really close to the radar site, you got to go up to tilt 2, tilt 3 to really get a sense of what's going on, because you're almost, like I said, it's too close. And it starts, and not to mention the artifacts that can come with that too. There's all different kinds of weirdness that can happen if the radar beam starts bending or there's ground clutter. All kinds of stuff can act funky when you're really close to the radar site. Not to mention, when you're close to the radar sites, Daryl, I'm sure you must experience it at some point. It can create weird artifacts that trigger TVSs that aren't there, because the radar is just going off the mathematics of what it's seeing, but it's actual artifact and not legitimate, and then you get a TVS, but it's not really a TVS. And yeah, that's just one of those things that comes with, you see it 100 times, and you're like, okay, that's not real. One of those deals. All right, nothing heard there. We had 14 check-ins tonight, a little bit less than last month, but I said we'll step it up for next month. I said keep an ear out for as weather starts moving through. I said, we'll stand on the net as needed. You'll hear Daryl out here. You'll hear myself. And I said, trying to be on top of it the best we can. Although the last weather we had, the first of the real season here, that was an early one. That was like a 11, 12, 1 o'clock in the afternoon type situation. That's not the usual 4 or 5 o'clock in the afternoon rolling off the foothills type setup. The usual hail season setups. That was a little bit earlier on in the day. So hopefully, I said, we'll get some more late afternoon and evening. So that way, I said, I won't be at work. That's always a toughie. So thanks for checking in tonight, everybody. Hopefully you learned something. You found it educational. Again, you can learn more about this net, what we do, what we believe in, all that good stuff. Just go to coloradosevereweather.net, and you will find all the information you need. Don't forget also, if you're not subscribed to the SkyHub, email newsletter, go over to SkyHubLink.com, get yourself on the email newsletter list. You won't miss any updates, any changes to the net, times, adjustments, announcements. Make sure you're on that email list as well. So again, thanks so much for each and everyone checking in. I look forward to seeing you all in the next couple of days, because I am leaving to head to Denver tomorrow morning at 6 a.m. So I will be out there for a few days. So thanks for checking in tonight. We'll catch you again next month, in the month of June. Let me take a look, as long as I'm here. What is the first Tuesday in June? Let me take a peek here. We are looking at, it would be June 1st. June 1st. All right, so first of the month will be our next net in June. So until then, I'm sure we're probably going to catch each other with a weather net, but if not, we'll catch you in June 1st at 8 p.m. Mountain Time. And the topic, TBD. Don't know what it's going to be yet. If you have any thoughts, shoot me an email, and we can set something up if you have any ideas there. Thanks so much. This is P0LWC Net Control, now returning SkyHub Link to normal amateur use. Have a great evening.